Good afternoon, everybody. I want to thank you guys for joining us for the FDOT DDI Design Webinar Series on signalization, signing, and pavement marking. Today we have Danny Hendrickson presenting. Danny is a senior project manager with Burgess and Nyepel, with 13 years of experience, specializing in traffic operations and design. He's designed traffic components plans on several DDIs for FDOT, including signalization, signing, marking, and lighting in ITS. He also assists central office in reviewing traffic design plans for innovative intersections and interchanges throughout the state. So with that, I'll hand it over to Danny.
All right, thanks, David. A little bit of housekeeping first. This is number 3 in the series of DDI webinars. Just to keep everybody up to date, there's 3 more coming up, but it's going to be a little bit of a break in between, not till August 10th. We'll talk about traffic operations. And then also, everybody's muted. If you have questions, put them in the chat, and periodically throughout the webinar, we'll stop and answer questions. We're not going to wait all of them until the end. We'll stop as we go and answer anything that you guys have. And we appreciate any questions. We want to keep it interactive if possible, so make sure that we're covering the stuff everybody's most interested in. We'll be talking today about the traffic design plans, traffic components, so signing, marking, signalization, lighting, and then a little Ped bike multimodal accommodations as well. So we'll start off with the signing and marking. For DDIs, you're going to have a plethora of signs. A lot of what we are trying to do with the DDI is keep people going the right way to the right place, following the right movements, and not going the wrong way. The MUTCD doesn't have any specific explicit details. The practices are evolving. There's a lot of options, but the main thing is minimize confusion and keep people on the correct side of the road. I remember driving through a DDI the very first time. You don't necessarily realize that you're on the wrong side of the road, quote unquote, wrong side of the road. If the signage is good and the geometrics are right, before you know it, you're actually on the interstate on-ramp, because it's just smooth sailing as you go. So good signing, good geometrics are key. And if you wanted to, you could even set up your plans like this. There become so many signs in the interchange areas that sometimes a key and some numbering is helpful. First thing for any DDI, when you're setting up your guide signs, starting with a master signing plan is a good idea. This is required at the end of an IMR, an interchange modification report. A conceptual signing plan is required, but it's also a good idea because you need to figure out where.
Hey, Danny.
Mm-hmm.
I think you switched screens on us or something. I don't see the presentation.
Oh, okay. Got it back?
Yeah.
Yep, we're good.
All right. Master signing plan is it's a good idea in general to set up not only what kind of signs, but where will they be placed, how many, will they be overhead, will they be multi-post, ground mounted, and also make sure that you're following the MUTCD criteria for sequencing, and that you have all your signs that you need, and they're not, that way the other components, the lighting, the signals, drainage can know where they can put their stuff as well. So starting with these signs that you see here, this is the arrow per lane sign. You see a lot of these being throughout FDOT, throughout Florida, especially where you have a lot of shared lanes. Again?
Sorry, Danny, we lost it again. Yeah. Seems to be jumping out of presentation mode.
All right.
Yep, good.
Okay. This sign is from University Parkway. This is the first DDI in Florida, and is consistent with a lot of the interchanges that are being designed adjacent to this one. This has the shared lane sign, the shared lane arrows, where you have the through and the left turn arrow. We would prefer to just have one arrow per lane. That way you know exactly where things are going. But when you have a shared lane, this is how we've been setting them up. This is the consistent way we've been doing it. And then the question could be, could that cause a wrong way movement? So let's look at an example. So I'll admit this is the other direction from the sign that we just saw. That was eastbound. This is westbound. This is, and by the way, throughout the presentation, you're going to see a lot of project examples. We have been assisting central office in reviewing the innovative interchanges throughout the state as they're designed. So we have a lot of examples, and I'm not picking on anybody. In fact, this University Parkway DDI, we are designing the one just south of it, and we're using a lot of the same design principles and to be consistent, but also because it was done well. So this is my example, but I'm not picking on anybody. This is, if you're looking at westbound traffic, the shared left arrow, could that be a problem? Well, it's possible somebody might see that left arrow and take a left at this first on-ramp because they saw the left, there's a left. It's possible. What we try to mitigate that with our wrong way direction signage, with pavement markings, with striping, but it could happen. You can also have geometrics where this median comes out and overlaps with this island, and then that left turn is a lot less likely. But with that left arrow, there's also benefits. If you look at this outside lane or actually it's the inside lane here, that the left arrow is corresponding with, this is a through lane upstream of the interchange. So we're actually, this is telling people you're in a drop lane. It doesn't say drop because you can't necessarily say drop at this point, but that lane goes on the interstate. Even though it was a through lane back on the arterial, it's going to be an on-ramp lane coming up. So it gives early indication that you need to get out of that lane if you don't want to go on the interstate. So it's pros and cons. As I mentioned a minute ago, deciding how many overhead signs you want to have in advance of the interchange is important. This is a location. These are some plans we reviewed. This is preliminary. They're not designed. They're not built yet. But this location has 3 overhead signs in advance of the interchange. This location also has a ton of traffic. It's very congested. It has some unique on-ramps downstream. So this is a location where it's good. You're giving people the early notification of which side of the road to be on, and that's helpful. So that opportunities for multiple overhead signs, again, congested interchanges. If you have shared lanes, it's also good to tell them this lane is a drop lane, the other one is not. And then another thing to consider is what interchange are you replacing? So for example, this is, if your previous interchange was a loop ramp, you're going to be on the right side of the road. This is in advance of the interchange. You go on the right side, you take the loop, you go on the interstate. Well, if you're building a DDI, now they're going to be on the left side of the road, and they're going to take a left. Now, if you commute this road every day, of course, you're going to pick up on that pretty quick. But this example is in Sarasota, Manatee County area where there's a lot of seasonal residents. They don't come that often. So that first time they go through the interchange after it's built, you just want to give them that early indication that be on the left, not the right. And then for a smaller interchange where you have fewer lanes, less traffic, it's easier to make a last minute lane change. This is where you can then have, ground mounted signs, both in advance and at the on-ramp locations. It's also important to note that if the interstate goes under your arterial, you don't have a bridge to mount signs to. So things are just generally going to be ground mounted. So that was the guide signs. Let's talk about signing at the crossovers. This is University Parkway. The signs on the mast arm. We've seen a number of these through lane signs, but in general, you're just trying to give that positive indication. Go through. You're not turning. You're going through the intersection. You don't necessarily need one for every single lane, especially like here we have 5 lanes. That would, your mass alarm is going to have a ton of clutter up there. So do what seems necessary.
Yeah,
Brian,
so
go ahead.
yeah, that's good. So, so what Danny is referring to, obviously what we're trying to do is avoid confusion for the driver as they're approaching the DDI itself, because it is innovative. It is, a little different, likely. When we're looking at the signing and pavement markings, and Danny, your screen keeps kind of jumping a little bit. It looks like it's not in. I'm looking at 2 screens right now. There we go. So for sign and pavement markings, we want to make sure that we're identifying the correct or the appropriate design vehicle. So especially for these dual turns, and so as you're looking at the dual turns, oftentimes what we say is, it's a semi or it's a WB, whatever truck that we've got designed for the interstate alongside a single unit truck. But the challenge is we don't designate which lane the semi is in. And so with that being the case, if you kind of look in the upper left corner, for example, one thing we really like to see is on a dual turn lane, put that cross vane striping, put that excess pavement in the middle of the 2 lanes. And the reason for that is because that allows a truck to utilize that pavement no matter which lane they're turning from. So if they're on the inside lane, they can kind of leak up into that striping lane and allow the trailer to stay in the ramp pavement. And if they're in the outside lane, they can keep the cab in their lane and the trailer will drag into that striped lane. So in the upper right kind of shows in the inside lane, here's what the truck would be doing. The lower right would be, or the lower right would be what would happen if that truck was in the outside lane turning. So next slide. And so this is just kind of zoomed in, showing again, dual turn lanes. This is following the DDI design criteria that we've developed, D217. This shows that striping in the middle between the 2 lanes. So this is the preferred way to show turning movement for how you stripe the multi-lane ramps. Next slide. So this is just an example of that. This particular location here, you can see that green crosshatch on the left image is that cross vane, that striping in between the lanes. Next. And this shows this same location. There's a truck on that outside lane. He's leaking down into that striping. Next. And you can see he actually is in there. So by putting that excess pavement in there, he's not creating a concern with the vehicle that's adjacent to him. But it also, in this particular location, we actually showed enough width of this ramp that we could actually turn 2 semis at the same time, which is not necessarily normal, but understanding the site constraints, that's the reason why we did it here. There's a lot of truck traffic on the other side of the interchange, both on the north and the south side, so we could not dictate that the truck would be in lane 1 or lane 2. But the reason too for the striping is breaks up that pavement, because that ramp actually at its widest point, as you can kind of see how it opens up, is wide enough to actually, it's 44 feet wide, which would have allowed 4 passenger cars potentially to sit on there. And the problem is there's only 2 receiving lanes outside of that intersection. So from a safety standpoint, putting that cross hatching, that vane striping, helps dictate where the passenger cars go and allows the trucks the extra width. Next. I think it's you.
Yeah, back to me. So we talked about wrong way driving a little bit before, but this is straight from the FDM Exhibit 230, which is in the signing marking section, showing how we're going to set up the signage for wrong way driving. The FDM actually mentions 9 different wrong way driving countermeasures that are shown here on this graph, on this exhibit. I'm just going to talk about a few which are highlighted. The interstate route shields, they would be upstream. Then you have your through arrows on the far side, and then another set of route shields downstream, showing which lanes go to the interstate and which don't. 2 4 dotted skips through the intersection, so you want to help guide the vehicles through. And this can get a little clustered in there, especially where you have all these lanes. This is what, 1 2 3 4 5 lanes per approach, so there's a lot of dots in the middle, but for a driver's perspective, it still does help guide them through. And then signs, we have our turn prohibition signs, the do not enter, and the wrong way. The other thing we have here is the wrong way driving systems that the recent design bulletin came out, and these are starting to be implemented throughout the state. This is a detail from District 5 from the Smart Roads website, where it lays out some detection zones where we're going to have our detection zones, as well as the follow-up zones. And what the wrong way driving system is we have the detection. It's looking for vehicles going the wrong way up the ramp. If it detects that, there's some LED, there's a red RRFB, and that would go off down here to help tell the driver, hey, you're going the wrong way, turn around. Assuming that driver is, not impaired and it was an accident, they can then pull over and start going back the other way. But that system will also send confirmation. There's CCTVs that will send a confirmation to the traffic management center, and they can, dispatch the highway patrol and hopefully stop whoever it is going the wrong way. These are also, they do have wireless or fiber communication to the traffic management system center, so that they can see what it was exactly that went the wrong way up the ramp. On to signals. First thing you want to talk about for the signalization is, where do we put the mast arms? I have never seen a DDI with span wire. They may exist, but it's almost always mast arms. And the best place, just like a box span, you would have your signals on the far side of an intersection. We want to try to do the same thing for a DDI. So you can see here, this pole is placed downstream on the far side. Stop bar is right here. These are your indications. And this is just a 2-lane DDI. It seems like a lot of the ones we've built around Florida are a little bit bigger, but here it is in plan view. And again, we want to put those mast arms on the far side of the intersection. So we'll kind of go through a couple of approaches and see the different, kind of intricacies that can happen. But there's our stop bar. Here's the corresponding mast arm in blue. So this is good. We're on the far side of the intersection, going perpendicular to the approach. Now we'll go westbound. There's the green stop bar, the green mast arm, also good. One thing to keep in mind is the sight lines. So if you're a car sitting here, you want to make sure there's a clear sight to that signal indication, and it doesn't get blocked by the other green, well, they're not green, the other green mast arm here. So this was good. This meets the site. We're on the far side of the intersection. Our sight lines aren't blocked. All is good. Here's another example where somewhat modified. Couldn't do it exactly, but we'll walk through it again. Here's our first stop bar in green. The mast arm is on the far side. We're good. The other approach, here's the stop bar again, direction of traffic, and the mast arm is on the near side. Now, why is it on the near side? Because if this one was on the far side again, it would be blocked by the opposing arm. So when you're laying out your poles, just keep that in mind, that these things are all generally the same height. They have a lot, they have more signs and signals than a normal mast arm because of all the restriction signs and through arrow signs. So it's important to keep that in mind. One more example here. This is near side, and again, the reason that this one is not on the far side of the intersection, it would have had blocked from the opposing mast arm, but look at this dotted arrow. That's the driver who's going eastbound. That's their view upstream of the intersection. They're looking way up where this mast arm is. If if the far side mast arm had been used, look at how far away their sight lines are from these indications. So that's another thing to keep in mind. It's not just, is there blockage from the opposing mast arm, but what's the driver's view as they're approaching the crossover intersection? There can be so much curvature in DDIs at that crossover that the upstream view of drivers is nowhere near the downstream, and that has to be kept in mind.
Danny, this is a great point. If you go back that one slide of just remembering that how important it is to work geometrics and the traffic folks together. You don't typically obviously lay out your signal pole layouts and your mast arm locations early in the geometric design, but you need to be thinking about it, because there's some modifications that could have been made, maybe not so much on this one right off the top of my head, but on the previous one, because it was such a flat crossover angle, that may have been beneficial to improve that that visibility of the overhead mast arms. And the other thing to think about is obviously these positioned in where your stop bars have to be. So the farther back you have the stop bars, there's other challenges with lockout and curvature as you're passing through the stop bar. So just something to think about. It's good to make sure that we are talking amongst our disciplines early in the process.
Absolutely. Thanks, Brian. And I know everybody loves laying out mast arms as much as I do, so I have one more example where we have this is where a single arm was used for both approaches. The federal highway guidance on diverging diamonds does basically use this as an option. But look at what this looks like in practice, where you have one arm for both approaches. Here's the green is the signal heads for this westbound direction, and then our blue for the eastbound. So first of all, you have 7 signal heads and then 6 signs on one arm. So this thing is very, very loaded, not overloaded, but loaded up. A lot of clutter, visual clutter for drivers. And in this case, this is another sight line issue where this green arrow is the westbound upstream driver's view. And this is the worst case, but this is one of 3 lanes. Look at where this driver is looking in advance of the intersection. He's way down here. So if this is the option that is desired, this is where we definitely want to have some supplemental signal heads installed. They can be installed on the pole or just on pedestals, and we'll talk about those in a little bit. This is just a visual view of what a single mast arm for 2 approaches would look like. Signs and signal heads everywhere, and then these little arrows amongst them telling you to stop and go. Just always have to consider drivers' ability to pick out the important parts of so many messages up there. When it comes to, again, laying out our poles, we have to put them where they make the most sense for traffic control, of course. There's certain MUTC criteria and just general common sense about where those poles need to be. But when it comes to constructability, it's helpful if you can place those poles in a location where they can be built without having to rip out the old road. So this yellow highlighted area is basically the limits of pavement for the existing road that's going to be torn out. And then these blue highlighted areas are the mast arms. Well, they're all within the pavement. So none of these can be built ahead of time. They would all have to have a temporary signal or built-in phasing. And sometimes that's your only choice. But if you have the option, it can be really helpful for your MOT phasing, for the contractor, for cost, if you can get those mast arms out of the existing pavement. And here's an example of that, where these 4 poles are all located outside the existing pavement, which is highlighted in yellow. We have reviewed some plans where it is glaringly obvious that it was more important to put the pole outside the existing pavement than to maybe put it in the right spot or consider economics. So if you have to build a pole like this one, for example, at the top, this looks to be, I don't know, it's obviously very much longer than it needed to be. It could have been placed towards the bottom of this this median island, but if you can build it ahead of time, then maybe that cost benefit was worth it. Hey, Brian, do you want to talk about some of these supplemental head locations?
Sure, absolutely. But before we do that, David, I don't know if you could see them, but it looks like we got a couple of questions. The first one I think that I saw, I think I can address. It says, do through lanes in the crossovers need to be designed for simultaneous WB62FL trucks without conflict, or can we assume that one truck occupies the entire gore area between lanes? So I guess to me it feels like there may be two pieces to this question. The first one I think it was asked was, do the through lanes in the crossover need to be designed for simultaneous truck movement? So I would take that to mean these are not the traffic that's coming or going from the ramps, but this is actually on the arterial going through the crossover. And in those cases, we typically say yes, we would want the lane width to be appropriate no matter which lane the truck's in. We've typically seen lane widths in that 14, 15-foot range in the curvature and through the crossover intersection. And then we see, that reduction in lane width as they get outside the crossover area. And then when you ask, can we assume that one truck occupies the entire gore area between lanes? If it's like the two lanes, if it's the two lanes that are turning from the ramp, so like in the image you see on your screen in that bottom right quadrant, that north to west ramp has that striped pavement on the ramp between the two lanes. I assume usually a truck can take that whole striped pavement in between the lanes. Because if two trucks are turning at the same time, they tend to space themselves enough that they don't conflict immediately. Yes, thank you. So hope that answers.
I would agree with that, but you have to look at the truck volumes and the lane utilization through there. In some cases, you may be set up to have side-by-side truck traffic, but in general, I would agree with you, Brian. I think you would want to allow the trucks to pass through without encroaching into the adjacent lane, but they would not need to be side by side with another truck.
Yep, perfect. And then Danny, it looks like there's another question that I'm probably going to throw to you, which was design variation needed for mast arms in the medium? ?
That's a good question. We have not gotten variations for them in the past because these medians tend to be, well, let me go back to this one. These medians tend to be rather big. So these are not like, typical median 22 foot, 12, whatever it is on an arterial. These are pretty enormous islands. At the same time, we typically don't put things in the medians or the islands. I think if your district requested a variation, you could do it. I don't believe we have done it in the past. David, did you have any thoughts on
that? To be honest, I would have to check and see. I'm not sure if the variation is needed or not.
Okay.
Okay. And I did see a comment in here. I don't know if, I'm hoping others can see on the screen. Danny has a little red pointer that he's using as his mouse. Sometimes in the presentation, I know I can see it on my screen. I'm hoping you guys can as well, but it looks like one person could not. And then David, I don't know if you're muted, but I think I'm getting feedback from you maybe.
Yeah, I'll mute right now.
All right, thank you. All right, so let's move on to we're talking about these traffic signals. Let's talk a little bit about signal head placement, and particularly that supplemental head. It's again, we're trying to minimize or avoid confusion in a location that is different than what a driver might consider to be traditional. So next slide. So let's talk about first on the east side of the interchange here. This mast arm that you see, this is the signal for the ramp. It's circled in black. Next slide. So this again shows that view from the ramp. The signal mast arm in black, those signal heads are all pointing to the stop bar, as you would suspect. This one on the far right here, circle in black, is also pointed to the stop bar, good supplemental head. But the one in the middle, as you notice, is pointed down the ramp. So as you are approaching the ramp, or approaching it, oh, a little fast for me here, Danny. Thank you. So as you're on the ramp approaching the crossover intersection, you can see I'm looking over towards my left, and I can see I've got a green indication, so I know as I'm making this curve that I can continue through. So this is what I would consider to be a acceptable practice when it comes to visibility and reducing confusion. Next. So now let's take a look next at the signal head on the west side. So next slide. Yep, next one. All right. So again, if you hit once, yep. So that where that's circled is the mast arm. Again, pointing to the stop bar, as you would suspect. Next one. This is the supplemental signal head in case there's a truck beside you and you can't quite see the mast arm. You can see this one that's farther over to the right. Again, pointed to the stop bar. This one in red though is the challenge. So this one was aimed basically so as I'm approaching on the ramp, I can see that supplemental signal head. This image on the left side now, if you hit it one more time, shows basically from a driver's perspective as you're approaching this intersection. Hit it one more time, Danny. There you go. You can kind of see, all right, so I'm sitting here at the start of that arrow, looking up. It's the same vantage point from a top-down view that is the driver's eye view on the right. So kind of give you some perspective of where that supplemental signal is. And what you'll notice by this image is the supplemental signal that red arrow is pointing to is actually for the right turn. It's not for the left turn in this particular case. But the problem is, if you look at the image on the right, how do you know that? You're looking at this, you're approaching it. How do you know which way that goes to? Next. And so that's the key. It's like you're looking at this supplemental signal head, you don't know which way it is, so that can be confusing because obviously the signal head on the right turn, or the signal on the right turn, and the signal on the left turn are opposite phases. So when one's red, the other's green, and vice versa. So next. So one of the things that I really like to see is the use of these arrows. So you can kind of see it here, and it's circled in green is a diagonal green arrow to the upper right, if you will. So as that driver in that white truck is approaching from a little bit farther back, he gets an indication from there as to that his direction, which is following that arrow, is green. Just real quick before you change this, Danny, if you happen to notice here, we don't circle it, but the left-hand signal head is a green arrow to the left. We see that occasionally. This is that free flow left-hand movement that makes the DDI so efficient and why they're so beneficial. In this particular case, this one, there's a pedestrian crossing there. And so with that signal, a pedestrian could activate it and actually stop traffic with that signal head. Again, that green arrow helps at least a driver that's approaching it to turn left, sees the green arrow, recognizes they can turn left. So maybe a little bit hard to see, but I'm driver's viewpoint. This supplemental signal head here is a green ball and not an arrow. So confusing. Next. As to which one that points to, especially given that we just showed you that there's some locations that actually have a signalized left turn for a pedestrian crossing, which this one has on that free flow left turn. Next. So this one was, again, that concern of that green ball. And, it's funny, I'm actually standing at this location, taking this picture. And unfortunately, it was because I was reacting to, there was a vehicle that was approaching this movement that was turning left. So in the free flow, if you will, they saw the red arrow and they stopped. And when they stopped, which again, that red arrow, or that red ball, I'm sorry, was not meant for them. It's meant for the through movement if you're angling to the right. But because they stopped, the vehicle behind them, who's also going to the left, assumed it was a free flow was shocked to see a vehicle stop in the middle of that ramp, basically, and almost hit him. So all I got to hear as I was kind of walking through was the squealing of tires and a near miss. And by the time I could get my phone out, they had and to take the picture, they had kind of cleared it out. But those are the type of things that we're constantly trying to avoid. We want to minimize that driver confusion as much as possible. Next.
Yeah, Brian, I think it's important too to know if you don't, the confusion happens because you don't have a signalized left turn on ramp. When you have a signalized left turn on ramp, you think about that. You think about the need to differentiate between the right arrow and the left arrow. But when you just have the through movement, you don't have a signalized left turn. As a designer, you may not necessarily even think about it because the through movement gets a ball to go through and on the supplemental. At least that's what your thinking might be. So just something to think about. Take a step back and picture yourself going through it.
Yep. And real quick, Danny, we've got a couple of questions here that might be germane here. One of them is, how do you deal with maintenance of the signals?
I'm not exactly sure. I'm not exactly sure what the question's asking. I'm guessing it's maybe related to placing them in a way that the maintaining agency can get to them to maintain them. But
yeah, that might be Paul. If you're able to maybe add a little clarification to that question or reach out to us afterwards, we'd be happy to respond. I think if it's just that, especially if it's a single mast arm and there's signal heads, pointing in both directions on them, yeah, it becomes a challenge because you end up, potentially closing one or more lanes if you have to get in from a bucket truck or something to that effect. So, and you may, yeah, I mean, that's the question of would you have to shut the intersection down? That's a good question. That's something to always think about. And I'm glad you asked the question because you definitely want to make sure that you're not creating a maintenance nightmare for the operations staff that's going to have to maintain this thing after it's constructed. So it's great question, great thinking, certainly. I don't think there's I don't think there's a specific answer that can be done, but just something that I would recommend you think about. Dan, there's another question. Is there a concern with the supplemental signal head not having the same direction arrow versus a green ball for the main signal?
To me, not really. I don't think somebody's gonna, as they're driving, necessarily compare, well, that one is diagonally pointing me towards a through movement, but the through movement has a ball or a straight arrow. I think if you're giving clear indication, then the driver will kind of the driver will understand what the message is if the message is clear. That's why those balls, if there's a question about it, maybe don't use a right arrow, maybe use a diagonal arrow. But it does kind of depend on the geometrics in the situation, but it's a good question. Okay, is that all we have, Brian?
Yeah, I believe so.
All right. Here we just wanted to kind of show a couple examples of different signal indications again. So these are for the overhead, the primary indications. These are just the balls, basic green balls. This next example is where they chose to use the through arrows. I believe in Florida that we are doing both. It can be up to the district or the designer, but we are, and it may also depend on the geometrics, but I don't know that there's necessarily a wrong answer. It may be more of a preference. Here's one other example with the diagonals. I don't know that we've used diagonals in Florida for the primary, but again, that could be a location-specific need.
Yeah, we've seen the diagonal arrows nationwide being utilized a little bit more simply because it just reinforces that need to stay to your left, in that particular direction when you're approaching that crossover. And so again, trying to deter that through movement, that right turn, if you will, that would be in going the wrong way. So that's typically what we've seen. Again, anything we can do to kind of reinforce what movement the drivers should be doing.
All right. Okay, here we want to talk about off-ramp turns. So We don't always signalize right turns at an off-ramp where there's a lot of traffic, a lot of congestion. Maybe even during certain times of the day, we would signalize an off-ramp and restrict right turns on red. With DDIs, it's a little different because here, a driver's used to looking back. You know, traffic would be approaching from the adjacent through lane, the closer lane. So the driver's used to looking in this direction of this green arrow for oncoming traffic. However, in a DDI, the traffic is coming from the other side of the road. So that's one thing. A driver has to be looking in the right direction. The other thing is that when that opposing through lane has their green, is when we would want to have the red for the off ramp. Like it's only a two-phase signal. We'll give them their time, but generally we want to give the opposing through movement their full green time as well, and not have vehicles coming out in front of them. This is a similar graphic just showing that vehicles are the expected oncoming traffic for a traditional intersection. This is where a driver might be looking, but the actual oncoming traffic is from the other side of the road. This is what just the off-ramp would look like from a street level view. But just one other thing we wanted to point out is important. In Florida, you can turn right on a red arrow. So you have to have the no turn on red sign to actually prohibit a right turn on red. Okay, pedestrian signals at a DDI, we're going to have Ped signals. It's a two-phase operation, so Peds it's very safe crossing for pedestrians. But the median island here can be kind of tight. So there's a couple different ways you can set up your Ped signals. You can put them, both on the wider side of the island, which is the first exhibit on the left. That way there's more room for the Ped refuge within the median island. And the exhibit on the right is where you're putting the Ped signals on the right side for each direction across the arterial, so that you're trying to avoid confusion. You don't want pedestrians to hit the wrong button because they just weren't aware which one was the right button. So here's kind of an example of a Ped signal layout. What's difficult when you're designing these is it can be difficult to meet the 10-foot separation. Typically, you'd want 10 feet between your Ped signals in the median, but because that is the most narrow point of the median in a DDI, it can be hard to meet that 10-foot. So one option that you could do, if you moved the entire crossing, in this case to the left, where the median is a little bit wider, you would be able to meet that 10 feet. However, there's drawbacks from doing that. You're increasing your red clearance distance. If you moved all the crosswalks to the left, you would have one of them encroaching on an off-ramp. So, there's pros and cons of both. But what you don't want to do is combine the Peds onto one super cluttered pole at the very narrow point of the median. This is actually straight from the DDI guidance handbook from Federal Highway, just kind of exhibiting a confusing Ped detection, Ped signal setup. And there's also insufficient space within the median refuge. So avoid this scenario. And even if you have to put them on separate poles, that would probably be preferable than one overloaded pole. And then quickly, I want to touch on the signal cabinet options. You can have one or two signal cabinets with a DDI. There's pros and cons of both. Depending on how big the interchange is, you can lose voltage drop from running your signal cabling all the way from the middle of a interchange out to your two crossover intersections. Also, technicians may not be able to see the signal faces and indications. They can't do testing if the controller is all the way in the middle of the two. So that's a drawback of doing one controller. Having two controllers, as long as they're interconnected and they keep communication, it can be a simpler setup, and it allows the technicians to see the operations of the signals from the cabinet. So, there's pros and cons of both, and some of the more detailed things are listed here. Last thing I want to talk about is multimodal pedestrian accommodations. There's two ways for Peds to get across the DDI. They can go down the center, or they can go on the outside. on the bottom picture here, you can see there is no center. So clearly the pedestrians are having to go along the outside. Again, in Florida, most of our interstates go over the surface road, not under. The interstate doesn't go under as often, so down the center is what we prefer. This is a view, that's a pretty narrow center median. Skip this one. This is showing the walkway and the path for pedestrians through the DDI. So the top is the center walkway. That's preferred in Florida. Again, there's fewer conflict points. If you look at the bottom diagram there, you have additional conflict points for the left turn on ramps. So if you can put the PEDs in the center island, you can avoid that conflict. You can also avoid having to signalize those left turn on ramp movements. So that's fewer signals and a simpler design. There we go. Again, we avoid.
Yeah,
this impact.
Dan, I can jump in on this one. So, again, what we're looking at here is when we're, this particular example is that center walkway, which is what's preferred in Florida. But one thing to focus on is making sure that we're providing that line of sight between the pedestrians and the drivers. So that red arrow you see there is, I got a pedestrian that's standing in the median and he's getting ready to step out, to cross the road. Make sure that that car that's at the stop bar or approaching a stop bar can see that pedestrian and vice versa. So next, same here. So pedestrians getting now to cross the ramp, which again, ideally is at a signalized crossing, so that gives the pedestrian a protected crossing. But let's make sure that the pedestrian sees the car, so that in case the car, accidentally or whatever blows the the traffic light. So let's just make sure that the sight line is visible there. So next slide. And then, yeah, I mean, as you're getting a pedestrian to get to cross the roadway, from the median, it's great because the pedestrian, when they cross the road, it's a one-way crossing, and they look left first, which is meets expectations. So those are the type of reasons why we really like to see the pedestrians down the median if possible. And these show just that, when you have the pedestrians on the outside, making sure that they can see. I think is there an animation on that one? I can't remember.
No.
Nope, but that's okay. But it's just making sure that we can see, pedestrians can be seen both, when it's on the outside, there's nothing in the way, for that sight line. And I think this slide kind of drives that home as well. See how they keep going. Yep. So just making sure that everything is visible. Next. And then we already touched on this, that having the right turn on reds give the pedestrians an additional ability to cross at a controlled crossing. So, yep. And then this just shows, again, when we're talking about pedestrians crossing on the outside, make sure if the freeway goes over, for example, hit the next one, that your bridge pier is out of the way. So that it doesn't impact sight line. If the freeway is down below and the arterial is up above, make sure that the bridge parapet of the arterial doesn't block the pedestrian sight line. And then certainly wanting to make sure that we position these as perpendicular as we can to limit the amount of exposure that the pedestrian has within the pavement, but also let's position the crossings close to the arterial. Because for one, vehicles that are approaching that crossing, that they're already looking straight ahead. If that pedestrian crossing has slid up the ramp a little bit more, by then the vehicle has made their decision to get onto the ramp, and they're probably looking to their right or to their left at the other ramp to find their gap within the vehicles, and they may not be looking at the pedestrian crossings. So that's why we like to see those pedestrian crossings closer to the arterial. And Danny, jump in if I can't remember where. So
I want to make sure we get to some of the questions, so I'm gonna go through these a little quicker. But for bikes, we talked about that. For bikes, there's 3 options. You have separated bike lanes or shared use paths. You can have a marked bike lane, or bikes share the road. But the last option, sharing the road, should be used in lower traffic. Here's the path through. The bikes basically just follow the cars and they stay to the right of the cars. And again, they can be separated or with traffic. One example we wanted to kind of highlight was this is a long keyhole approaching the crossover intersection. So the red is the long keyhole. It's between 2 exclusive right turn lanes and 4 through lanes. And this is a long way. Upstream of this is there's a keyhole at a signalized intersection, and then it's a feeling of, you know, a bike being right out in the middle of the road with traffic, but these are exclusive right turn lanes. So hopefully the merging all happened, you know, to get into that right turn lane happened upstream of here and everybody's positioned. What if it was an option lane was a scenario that we had. So what we tried to do was shift traffic or shift the bikes. At this first box here, this is where, well, let me go over the scenario. The scenario was that we had an exclusive right turn lane and a through right turn lane. So if you look at the design standards where you have a drop lane, you would put a bike keyhole between the right turn lane and the through traffic. But in our scenario, the adjacent lane was a shared lane. So we didn't want to put a keyhole between a lane where cars are going to be merging. Some of them are going to go straight, some are going to turn. So what we did was put this yellow as the path of a cyclist. In the red box, this is where we changed, we took the bikes basically off the road. We put a ramp into a sidewalk, made it a wide sidewalk, and then the bikes and the pedestrians could share it together. Oh, there's the box. I always forget about the animation. And then at the bottom here, this is where the pedestrians and the bikes would cross the free flow ramp together. That ramp is signalized, and then they can get back onto the bike lane once they get into the island, and then go on their way, you know, in the adjacent bike lane like they were always going to do before. So that was just kind of a unique solution we thought to a problem that will probably come up again with shared on-ramp lanes. Oh, same slide. And then just a last little look right. I don't know that I've ever actually seen that pavement marking before, but it looks fun. Quickly, lighting.
I'll start real quick, Danny. It just reinforces if the pedestrian, if they're on the outside and they happen to cross the crossover intersection, the arterial, they're looking in a different direction than they're trained to look initially. So it's just more of that validation or that push to make pedestrians look to the right in that particular case.
Okay. Couple just quick on lighting. This is not any different than any other interchange type, but with the big push for pedestrian safety and lighting and crosswalks, you can find yourself in a situation where maybe the existing interchange had high mass light, which is this orange, covers a huge large area, but it's not necessarily very the illumination levels are not that high, and you will end up adding conventional poles to get intersection lighting. You could have high mass. You could have, and you'll have underdeck lighting too. So you just end up having all sorts of different light. You could have different lighting configurations within the interchange. You don't necessarily need to rip all of one out to replace it with another. And that was it. I don't know, do we have any other questions before our time runs out?
Yeah, so it looks like, let me jump in here real quick. It looks like, see, with the mast arms and the median islands, the median curb and gutter must be type F. Do we need variation type F curb and gutter in the median?
Yeah, that is something that I would have to check on. My initial thought would be no, but I'll have to check on it, and I can follow up with an email to answer that question.
Okay, good. The next question said, what about long all red times, ? That was it. And I think Cody maybe was referring to pedestrian crossings with the, I think it was when we were talking about the pedestrian crossings, probably the crossover intersections. So, I can tell you that with those, you know, I'm never a huge fan of all red if I can help it, especially with the two-phase signal. There's, usually ample amount of time for each phase to allow for pedestrians to make that maneuver, and they're not normally the critical element, if you will. There's usually so much green time needed for the cars that the pedestrians can make it across. So, Cody, I don't know if that's exactly what you were asking. If it's not and you're still on, if you could maybe just either send a new question or shoot an email afterwards would be great. Next one, for off ramps, instead of using supplemental signals as shown in your slides, why not have the advanced mast arm placement a third of the way back, signals with flashing yellow lights with signs, flashing light prepare to stop, red light ahead, with each signal head positioned over the lane impacted by the red light ahead. And when the signal is green, the advanced mast arm flashing yellow light is not active.
We've done, instead of putting pedestal mount supplemented head near the stop bars for the off ramps, on one of our designs, we did do a mast arm in that splitter, the island separating the off ramp left turn from right turn. It's a big median. And we did put a mast arm there with indications for the left turn and the right turn that are visible from much further up the ramp. The mast arm is not that far up the ramp itself, but being that it's much taller than a supplemental head, it helps for upstream to see what the signal is.
Yep. Okay.
I would say that the placement of these mast arms is a context-sensitive item, but the main theme is to make sure that there's good visibility on the approach.
Okay. And then let's see the next one. Let me see if I make sure I'm right here. If a paved bicycle lane creates confusion for motorists because it looks like the road, do you recommend green bicycle lanes? I'll first give you my answer and I'll let David jump in with his in case it's different. My recommendation is rarely green. I assume you mean basically paint the bicycle lanes with green paint. I don't like those for the long durations because of a maintenance issue. What I would rather see is it's certainly in the conflict zones where, say, a turn lane is being opened up, there may be a short segment of green pavement to kind of differentiate, that conflict zone itself. But otherwise, I think a lot of times I would say put maybe more frequent use of the pavement tattoo of the bicycle. So you put the bicycle pavement marking, in that bicycle lane, maybe a little bit more often if you need to. I think that's less of a maintenance nightmare than the green paint. But David, I'll let you maybe answer that as well.
Yeah, I concur with that. I think the main place to highlight with the green pavement would be just at the conflict zones, like at the ramp terminals where you got a right turn crossing over. And I think that's pretty much confirmed by the guidance that we have in the FDN too on bicycle lanes.
Yep. Will providing longer separation, parentheses opposite movements, at the intersections help improve sight distance, especially left turn movements? I'm trying to get exactly where we're driving at here with providing longer separation at the intersections help improve sight distance. Yeah, I don't quite know what that question is. I don't know, David, if you're following that.
I'm not sure.
Yeah, I'm not sure. We might need to get some clarification on that question.
Yeah, if we can get some clarification, that'd be great. Not a big fan of bicyclists being in the middle of the 4-2 lane for that long keyhole. Are there options to get the bikes off the road along the curb line? And I think Danny, you touched on that, I think, in the slideshow, about pushing them off and putting them on a shared use path or something like that. Do you think that's the best way? Is there any other ways you could think of?
That particular location, if you went upstream from where we showed you, it was already a right turn, or their keyhole started upstream from there. So yeah, I wouldn't want to be that bicyclist between 4 and 2 lanes either. So I think what we showed you as a possible solution to kind of kick the bikes off onto a wider sidewalk, that was what we decided to do. So that's an option. You can't put delineators, or I guess you could consider some sort of physical separation, but at the same time, then cars can't, if they're trying to make a late lane change, they would be locked out. So yeah, I don't love it either. And that's why we did something different.
Yep, that's good. I know it's 3 o'clock. We've got a couple more questions left. David, do we want to try to answer them, or do we want to shut down?
Yeah, if we can quickly go on and knock them out, that would be great.
You want to go ahead and read them, David?
Where are we at?
3rd from the bottom.
Let's see.
Yep, now 4 from the bottom.
With the LED crossing very far from the conflicting stop bar, they all read for vehicles with count greater than 6.
Yeah. Yeah. So I think we're talking about the red clearance for where the cars are going through the crossover intersections. You can do an overlap where it's kind of hard to describe without a visual, but it's a very long clearance from the through movement to get past the off-ramp right turn, because it's just a long physical distance. So you can program the controller for an overlap where it releases the opposing through movement after the other through movement gets past there, but before the other through movement gets past the off-ramp right turn. It can reduce the all red substantially, at least for the through movement, but the off-ramp right turn would still have a pretty long all red. You're right about that.
Okay, I think we've gone over. We can answer the rest in the email. So I want to thank everybody for coming, and hopefully you can join us for the next one. Thank you all.